Now, what we're going to look at is particular solutions using indefinite integrals. All right? What we're doing, we have been looking at indefinite integral with plus c. So we integrate, we know there's a family of curves. But this time, what we're going to do is, how are we going to find c? That's the important thing. So you know all the technique of antiderivative or integrals already. Now, we need to think about an initial condition. So here, we do have an initial condition now that we could solve for c. And there are other ways that you can do it. You've got graphical problems using first and second derivatives, stationary points, and points of inflection. All right? Various things. Now, so what is a particular solution? A particular solution to the differential equation, dy dx equals f dash x, is when the arbitrary constant of integration c is determined using a specific condition on the family of curves. So you know we can move the curves up and down, all right, along the y-axis, and we don't know what the plus c is. So here, once we know the condition, a specific condition, instead of a family of curves, we've got one curve, all right? And in some instances, we may need to use the stationary points or point of inflection to determine c. I'll give you examples. All practically what we're doing today is just examples after examples after examples. So we're going to start off with number one. Let's start off with integrating f dash x first. So this is the most basic example that you'll get, integrating f dash x. If you could integrate that, you should be able to substitute x equals to 2 into fx to determine what c is. All right? So, first straightforward example, fx is 3x to the power of 4 divided by 4 minus x cubed plus c. So now you know if I substitute x in, I get f2 equals to 7. So by substitution, you should be able to work out what c is. All right? I mean, in a test or in an exam, this could be the very first question, a warm-up question for you. All right? But I doubt that it will be this simple. Sorry, Caleb, this is a bit wet. I got it wet, but
oh, it's so good.
my fault. All right? So once you substituted the x value in, you could work out c equals to 3. Now, important, because you are asked to determine fx, you cannot just stop at c. You must write out the whole fx. I know the tendency is stop at c. Once you found c, that's it. But not quite. Remember, write the whole thing out because you need to determine fx. You are not determining c. All right? Try the next one, please. The next one, you should have all the technique of whatever it is already, all the technique of integration. So you should know, if I've got radical square root of x, it has to be x to the power of half. Yeah. And this, in this case, it's minus half. So if you multiply this into that, it's a bracket. I will rewrite it. Just a hint. This is what I do. I rewrite it that way. My tendency is I always like to rewrite. I don't like to have a denominator. Make life easier for yourself. Always do it that way. All right? This is from experience. Just because I've started out integrations quite a few times doing that. So from experience, never ever do that. All right? Once you've done that, you should be able to find y. Now, so you want to find y in terms of t. Differentiating, you've got a family of curves. And family of curve plus c, you don't want to see, substitute t equals to 1 in, and y equals to minus 3. This will be calculator free. Definitely calculator free. So substituting c equals to minus 1 and write out what y is.
That's correct.
Agree? Do you agree with my answer?
Because when you do it, you get 60 3 on 2 over 3 on 2. And when you evaluate that, you get 40 3 on 2.
Yeah, but it's just 60, so it should be 62 over 2.
Which one?
6t 3 on 2
3 on 2,
on
yeah?
3 on 2.
Yeah. So you remember divided by 3 on 2, so you can flip it over. See? Remember? If it is 60,
Yeah, but you have 1 minus 60 over 3 on 2. Why is that?
How is it 4?
Because that's the power. But the
You add 1 to the power.
yeah,
60,
that's a
yeah.
power. I've got to half plus 1. Half plus 1 is 3 on 2. Half plus 1 is 3 on 2.
But where'd you get half from?
Half from is the 60 times the square root of t. So t to the power 1.
Are they different terms? So it's 60.
So it is 1 minus 60 times t to the power minus half. So that is t to the power minus half. Correct? So this and this is minus 6. What is power? Is half. Correct? Alright, next. Example 3. This time, slightly more complicated. You are given the second derivative. From the second derivative, you know you're also given a condition f0 equals to 2 and first derivative at 0 equals to 12. Alright, determine fx. Now, from here, what you really need to do is
Xbox One.
anti-differentiate or integrate f double dash x, second
Yeah, onto the
derivative, then find your first derivative. Once you find your
Think
first
about the
derivative,
derivative.
you've got to find the c of the first derivative.
Just
Alright?
x
From there, you've got the gradient function. Then from the gradient function, you need to integrate it again to find the original function. So in this case, again, I rewrite. I will always rewrite. So that you know, for example, 2e to the power of 4x divided by e to the power of 3x is 2e to the power of x. Remember your index laws. And then minus 18e to the power, minus 18e to the power of 3x. Alright, from there, do your integration to first, to the gradient function, which is to the first derivative. Alright? You know that differentiating to, not differentiating, integrating 2e to the power of 2x is just 2e to the power of x. Alright? Here, you know that integrating minus 18e to the power of minus 3x. Alright? Now, think about when you're doing this. d dx e to the power of minus 3x.
Just separating the terms, right?
That is actually minus 3e to the power of 3x, correct?
I'll show you.
So therefore, the minus 18 is actually minus 3 times 6.
This?
Right? So what happened in
Just
this
use
case?
that, right? Just separate
This
the
will
terms.
become
And then,
6
of course,
integrate
what's the, you can rewrite this as just 18
minus 3e to the power of minus 3x. Alright? So therefore, I got 6e to the power of minus 3x plus c. Then, I use this condition. Substitute in there. So basically, we pick numbers that are pretty straightforward so that you know e to the power of 0 is actually 1. Alright? So you should be able to determine what c is, which is 12. Agree? Yeah? So, logically, step by step. So you now have the gradient function. Write the gradient function
Do you get c equals 0?
plus 4. Oops.
I got 2.
I forgot my plus 4.
Yeah.
Uh-oh, I don't know whether my solution will be right.
I got 2.
I forgot my plus 4.
What do you have for the anti?
No. Leave me alone.
Uh-oh,
Leave me alone.
I
Leave me
think
alone.
I think my answer will be totally wrong. Okay, that is a problem that I will make, not you, alright? I always have this, yeah. Oh yeah, I did. I did. Oh, I did. It's just that I didn't do it for the animation, I did. Whoa.
I forgot.
I did. So now you can integrate the gradient function of first derivative,
Yeah, I did get
and
0.
you've got another plus c. So
I got
c is
0.
just arbitrary.
Yeah, man.
I don't know.
Alright? So you can always keep on using c. I know some books use c1, c2, c3. To me that's too confusing. Just keep on with c. That will do. So because you will know that this c is different from that. Alright? Yeah. So as long as you do it logically step by step, you'll be fine. So now you've got F0C. The thing is, most of the time, like I say, we try to make things a little bit more straightforward. Because e to the power of 0 is 1. So therefore, you know that c is actually 0. So c is 2, sorry, not 0. What am I talking about? And you can determine fx. Alright? Are you all happy with the way I solve it? The steps that I've shown you? So I start off with from f double dash x, which is the second derivative, to f dash x, first derivative. And then I use the condition of f dash x to find c for f dash x. And then from there, I go to fx, and I use the condition of f0 equals to 2 to find the c for fx. So you've got to determine c twice in this situation. Yep.
Isn't it being minus 2 e to the negative 3x, not negative 2x?
Yes, it is negative 3x. I got this right, but I got that wrong. Oh, see, I got this minus 3x right, I got that wrong. Yeah, I'll change that. Thank you. It's,
Did you get 4?
look, I've done that many mistakes in my
Huh?
exam
Did you get 4?
before. It's not
What I
funny,
get for 4?
but I did.
Oh, I haven't finished yet.
Alright.
Ooh.
Ooh, that's not good.
I'm scared.
Oh,
Okay, listen to me, son.
Alright, this is 3. Minus 3.
Wait, how do you get?
Alright,
Yeah, it is minus 3.
it is minus 3. It's my fault. It's totally my fault.
Oh.
Alright, next. Here
So, how do you
I've
get plus
done
2?
something pretty
I did the exact same thing.
important for you.
But yeah,
I
but no, you're
highlighted
right, you're
the
right, yeah.
information.
It's 0.
It's
So
0.
this is what you need to do.
2, take 2.
Highlight the information. I normally in the exam, I always
2
have
take 2 equals 0.
different color highlighters.
2 take 2 equals 2.
So that I know when I highlight, this one
It's 2
is
with this.
related to that.
Then 2
This
minus
information is
6
related to that.
2.
Here, you're talking about oblique point of inflection.
Oh,
Now-
I'm retarded. We're actually brain dead.
If you have an
We're actually
oblique
brain
point
dead.
of inflection, what happened?
Oh, I was right then at the start.
Gradient
Okay.
I was
The
right
gradient
at the start.
changes what is
Red
what
ticket.
is d2x dy in that point?
no.
0, that's correct. So this information is here is telling you d2x dy squared is 0. Alright? This orange information is d2x dy squared equals to 0. Alright? And maximum turning point. What is it telling you? dy dx equals to 0. Right? So use the information there. All this. How are you going to, this is dy dx, yes. How are you going to determine the equation of the curve? Alright? Now the most important thing is, because you know the information,
I got
one,
x3.
and minus 11 d2x dy squared equals to 0, I will first derive
B, you get negative 9.
the second derivative so that I don't have to worry about b first. I start off
Just
with
sub
looking
in-
at a, correct? Because
Wait,
usually
what did you get for
when
A?
you
Negative
derive
6?
dy
Yeah.
dx,
And then
you actually
you
drop
sub
x
negative
from
1 to this,
from
right?
this.
Will get you 0 for the stationary point.
The derivative
It's
of
a
dy
max-
dx,
it's a
you
max
actually
turning
have
point,
a
so it'll be stationary.
and 6,
Yeah.
6x.
So 3
Right.
plus
So
3
here-
plus 6 plus B equals 0.
I do that because
Give me B
I can
equals
find
negative
a
9.
first without worrying about b. Yeah? So that is the thing that you need to be
Holy
able to
shit.
understand the
No,
question
no,
and
no,
how
no,
to
no.
solve it.
Bro.
From there,
holy
oblique point of
shit.
inflection,
Holy
d2y dx
shit.
squared equals to 0.
Yeah.
At x equals to 1. So you should be able
Holy
to
shit.
work it out. I'm going to let you work on it for a couple of minutes.
Oh my goodness. Oh my goodness. I feel so stupid. How do you get 0? How do you get 0?
I got C minus B equals 9 from the first,
5.
from the y
So
equals.
6 to 3.
Because I just got the original equation
How do you not get negative 6?
for what, for C.
Yeah.
So I got y, bx plus C.
Take 3x.
Yeah.
Take 9.
Well, I didn't know B before because it's brain dead, so I did this and then I got B.
Last rule. Yeah, keep going. Yeah, that's right. Continue. And last rule. Sign as a student. And then use your Shilton to do it.
Yeah.
And that's it.
How is mine not working?
All right. Next.
Is that 8 there?
So I can now solve for A, can't I?
There you go.
Because I know this condition. The oblique point of an inflection.
I got it.
So d2y dx squared
That's the
equals to 0,
negative.
and therefore a equals to minus 1. You got your dy dx. Now, you can solve for b. Why? You can solve for b at this point because dy dx equals to 0.
Sorry?
Correct? So you know maximum dy dx equals to 0.
Yes.
Solve for b. And then you integrate again. Solve for b and then you integrate.
Yeah, of course.
Solve for b. Agree? So you now have a. You've got all the tools that you can to solve problems like this. It's just how to link them together, that's all. You need to be able to link, make association with the questions.
I just got a bunch of self-hand equations, so I got so you can just so
just
many.
find, no. Yeah, and then you just sub it all in. And you find
Alright?
the integral.
Now, so you
Integral.
know all the
Other point,
information,
yeah. You can use
you
either
can
point to get
actually,
Yeah.
you can actually then
Yeah. You got everything else.
maximum turning point, dy dx equals to 0.
You just
It's
sub
not that you
one
don't know
point
the
because you're only
information,
solving for one
it's just how
variable,
you
right?
link it together,
So
that's
if
all.
you just sub in
Alright?
one, equals
Putting the
negative
information
one,
together,
you get C.
putting what you have learned together is what I'm now teaching you.
Why? Well, if
So
you
you
try
know
it,
all the
you
techniques?
see that you can rearrange it to solve for C.
So therefore, you know what b is. B equals to minus 9.
How? So you got this equation, right? Where B, you've got B, right? So you got
So
B
once
equals
you know b equals to minus 9, you can rewrite that dy
but the
dx
points on
and
the
work
curve.
backwards.
These are points derived from the original derivative curve. No.
Now,
The curve
when
has
you
a
work
big-
backwards, everyone,
Look,
to
this is the gradient
find
function
y,
of the curve.
y of
The
course has a
gradient
plus
curve
c.
here, yeah, the curve has-
How do you find plus c? You've got a condition there, minus 1 and 5 and 1 and minus 11. Use either point to substitute into y. Yeah? Use either point to substitute into y. Personally, I would use
I got
this
this
point because I've got a smaller number to deal with 5. But on the other hand, if you don't want to deal with minus
where am I
number,
tripping?
here you can use that. But again, you still have to deal with minus number, negative number.
That's 5 take 6.
5 take 6 equals -1. Negative 1 to the power of 4 is
Oh,
1.
it's fucking negative, bro. Oh my god, I'm missing
So
negative
everyone ready so
again.
far?
You leave 6 for C.
Happy with this? Happy with
Huh?
Negative 6
See,
for C.
you've got the tools. You're just putting all the tools together now. All right?
This is 6 negative C.
You're putting the tools together now. Oblique point of inflation, d2y dx equals to 0. Maximum turning point, -1 and 5. dy dx equals to 0. And then
My bad.
I use x equals to 1, y equals to -11. So
Did you get 5 on 6?
Yep.
if I've got it right, I think so. So c equals to 0. Therefore, you know what
That's
y
just
is.
dead, bro.
All right? Now, all this, if you disagree with me, you can just think about trying to use your class pad to prove that I'm wrong, all right? Or, you should, if you want to prove that it's correct, go back and use your class pad to
That is
plot that.
so dead,
You should work out where the oblique point of
this
inflection
radiation
is
stick
and
is
where
so
the
weird.
maximum turning
Huh?
point is.
This radiation stick is so weird, bro.
Yeah, I know.
All right. How's everyone going?
Good.
I've got, all right, I'm going to go to number 5 now. Can I move on to number 5? Example 5. So here, you've got, first derivative is this. And find f1 equals to 0. Determine x when fx equals to 11. Now here, you are not asked to find the equation of fx, but you still need to. All right? To solve this sort of problem, what I would do is I will actually look at this first. All right? So, instead of differentiating this, I'm going to differentiate 5 minus 6x to the power of 4. So if I have d dx 5 minus 6x to the power of 4, all right? Remember your power rule. You bring it one up. Therefore, when you look at d dx, you actually do d dx of 4 instead of 3. So you have 4, 5 minus 6x to the power of 3, correct? And then minus 6, which is minus 24, 5 minus 6x to the power of 3. Now,
Classic mistake.
this is one step extra, a few seconds extra, but then you can clearly see that
Classic mistake.
that is related to your
Bro, it's under. So that's
f,
negative.
your first derivative f dash x, correct?
I'm actually
Yeah.
going dead.
Got it? So what you do is you look at, forget about what is outside here,
Oh, I keep doing that. I've
You
done
look
that
at
like
this.
2 times.
Yeah,
today.
Sam, I did it as well.
and then
I
differentiate
did
that.
as well.
Instead of differentiate
Nah.
to 3, differentiate to bring the power up, because you know integrating, you're bringing the power up by 1. Yeah? You need to bring the power up by 1 by integrating. So looking at that, you differentiate d dx 5 minus 6x to the power of 4.
So
This is a technique I always use.
change the power.
When you look at something that you need to integrate, especially something to the power of something,
Shouldn't power
all right,
shouldn't power be 4?
differentiate
So
to the power of n plus 1 first.
Shouldn't the power be 4 then?
Sorry?
What, how are you supposed to
This is 4, yeah, that's correct.
Yeah.
1
This is 4.
to 1?
Should the 3 still be 4 as well or no?
Sorry, no. d dx is 4
So
Yeah.
equals
to
3.
the power of 3.
Yeah.
And then what is differentiate inside?
Yeah.
Differentiate outside first. Differentiate this first. 4, 5 minus 6x to the power of 3. And then differentiate what's inside. Yeah? So therefore, from there, you actually can straight away write out the function fx. So here, if you really think about how to find fx, is actually integrating 24 5 minus 6x cubed dx. All right? So I know that I need a minus here, so I put a negative. Negative 1 times negative 1 gives me positive. So therefore, that whole thing equals to minus 5, 6 to the power of x to the power of 4 plus c. Alright? Now I haven't written it down in my solution because I want to show you on the board what this is, how I actually derived that. To get there, I did actually work this one out as well on the side. Yeah. In the exam, if you can't see it, do it on the side because you should have enough space.
Did you get -3 or +3?
+3.
Happy with that?
Did you get +3 or -3?
I'm happy if you want, take a photo of this so that you can remind yourself what to do. Alright?
This could be right.
And then you could work out what C is.
How did you get 3x?
And then
fx equals, this is my anti-diff.
you know that the next bit, you know that fx equals to
I mean C for f dash x,
11.
3 for f dash x.
Alright?
Because I did this one.
Can I wipe this off?
How's it negative?
Happy with that?
Yeah.
Can I wipe it? Okay.
Yeah, true. I got C wrong.
So now, the next information you have. The next information you have is you want to determine x when fx equals to 11. Once you know fx, substitute y equals to 11 there. And you can work out
I got -3
if this is
for
plus 11,
fx.
plus 11, that will be 0. So 5 minus 6x to the power of 4 is 0. And you keep going, x equals to 5 over 6. That's all you need. You need to find x, determine
6.
x when fx equals to 11. Are you all okay with this? See how I did it step by step? How I went from this derivative. I look at this to the power of 4 first. From there, I integrate. Once I've integrated, I found C because I know f1 equals to 0. Then I want to determine x. So fx equals to 11. 11 equals to that. Rearranging, I've got 5 minus 6x equals to 0. 6x equals to 5, and therefore x equals to 5 over 6. So important thing here is using the condition. How we could use all the conditions given.
I could.
All right.
Is this
So
what you
I
got
did
for
one.
fx?
You go to this.
Your anti-diff?
I'm not sure your first.
So,
or
never mind,
this
never
one
mind.
as well.
That minus 1 to the power of
It's
4
I'm sure it's a negative.
is minus 1.
It's negative.
No, I'm not. I don't
Not
think
sure.
it is.
Okay, so the original function
It's
was
negative.
right? So if we bring this over negative.
So there's 1, because it's negative out there,
Yeah,
so it's minus 1.
times
All right.
I forgot you put the 10 there, so I was
Yeah.
fx 0 plus
Yeah,
Oh,
that
yeah.
is fine.
That was negative.
All right.
Yeah, so it's just
Example 6. Now, here, the condition is such that at the point 1 minus 1, the gradient of the tangent is 2. And then you got to define the rule. See, this question is sort of loaded because you already have 1 point. You know that whatever it is, fx goes through this point, correct? You know fx goes through 1 and minus 1. So that is one condition. The next, at this point, the tangent is 2. So f dash x is 2. F of 1 is 2. F dash of 1 is 2. So you've got the 2 condition there. You would be able to solve for the gradient function first, and then solve for the
C equals 1.
rule of fx.
C equals 1.
No, for the whole thing, but just for f dash x.
Oh, yeah.
Alright, so start thinking
That's right.
about how we're going to do this. Here, again, on the side, I did not show you, But I've did it this way. Minus 2x minus 1 to the power of 3 over 2, minus 3 over 2. That is what I wrote down. All right, on the side. All right, to work on this. And then I know dx of 2x minus 1 plus 1 is minus half. It's actually minus half. 2x minus 1 minus 3 over 2 times 2. So therefore I've got minus 2x plus minus 1 minus 3 over 2. Alright?
Negative 3.
C.
Yeah.
So I can actually straight away know that if I integrate that, it will be just that. It will be just this plus C. Yeah?
Yeah.
Understand what I'm doing there? Yeah.
How'd you
I'm doing step by step. But all you need is understand what I have shown you previously.
Well, look
the
at this.
technique of our integration.
That?
Yeah.
So I look at this,
Close to.
I know it's that.
So what happens when you
So
do,
I want to
do
find,
the differentiation of this?
if I differentiate this, what would happen?
Isn't it sine t
Plus 1.
into something?
Differentiate that.
No, you
I
bring-
got that.
So
Oh yeah, you have to differentiate
Yeah.
the top. Yeah.
Do a differentiation first. Differentiate whatever it is.
Silly,
to an,
silly,
uh,
silly.
losing the
power
basics,
plus
mate.
Silly,
one.
silly,
break
silly.
the basics down.
Alright? So, therefore, I know this is my, I can work, what else? I can work out f,
For 1.
fx plus c, and then you know that when it is 1, have I done that?
You get 2x take 1.
You know what? I've made a mistake. The tangent is 12. It's not minus 1. I've used y instead. My fault.
Yeah, yeah.
That should have been 2. Alright? That should have been 2. That should have been 2. So 2 equals to 1 plus 6, 1 plus c. So therefore c
Is equal to 1.
is actually equals to
What? What's the 1?
2 minus 1 is 1. Alright? So my fault there. I use the point instead of the gradient. So I'll change that when I upload my solutions. This is where I made a mistake. I was looking at this instead of looking at the tangent.
This question's got
So the
kinda hard.
tangent
You
is
have to be
2.
switched on for those.
So that
You
should
have to
be
be
2.
switched on.
My fault
Yeah.
instead of 1. So C should have been 1. Alright? So everything I do later will not be correct. I will redo that. So that's 2.
1.
So therefore that
The
is
power of anything is 1.
plus 1.
Right?
That should be
Because-
plus 1. Alright?
So, but this is just 1 square root 1. Because that's 1.
For how much is that?
Just realize that I've made a mistake here. I used the point instead of the tangent.
Nice, right?
I should have used the tangent here. The tangent is 2. Somehow I was reading this instead of that. Right?
Nice, mate.
So from there, it should be minus x only. You should be able to find what c is. So if there's minus x,
Let me.
that should be minus 1. Minus 1. So should be 1. Alright? Plus 1.
Don't do that.
What do you mean?
Alright, so I've
Don't be
corrected my
hostile to
mistake
that.
there. It should be fx should be that plus 1. So again, what you really need to do is make sure that you know how to rearrange your second derivative, and then use the information, the gradient at this point is 2. Alright? You know the gradient function, so you can find out the gradient function. And then from there, substitute work back in and use this point, -1. Alright? Now in the exam situation, what would happen is you would have lost mark for this, but you will get a follow through for that.
C is negative 3. No, it's not.
Oh, I've been up.
C is negative 3.
Alright, can you try example
quick
7
one, right?
please? Before I show you my solution.
Is she that quick?
Example 7.
I died straight away.
Last one.
I died straight away.
Negative 3. Yes.
Oh, I've written it out. I'm not going to show you my solution yet. Can you try the last one, please?
Wait, he got plus 1, so.
What? It's -1, sir.
I think he got negative on the coefficient at the front. Yeah. What?
-1 and -1
1 minus
cancel
C.
off. So there's -1, it becomes 1. Alright, that's the last one.
Wait,
It's my total startup. No one else's.
mine's -3.
So I think your function's like wrong. It's supposed to be negative 3 in the end, and then positive 2x minus 1 to the power of half.
Oh, yeah, it is positive here.
Yeah.
And I got it wrong.
Yep.
I made another mistake, should be positive 2x. I don't know why I copied that down as dear. Alright, it is.
Yeah, we're trying to anti-dip that. So you reverse engineer that one. So you added power to that. Yeah.
It's my
So
fault.
half times 2 is 1, but he put the negative there, which is wrong.
So it's not negative.
It is
Wow, that would have. If this is a 5-mark question, I'll probably get 2 marks only.
Oh. Caitlin got about 1 as well.
negative. What, you got about 0.
What do you mean? I got the question right first and you're like, nah.
Nah, but...
I had to check the
My fault.
differentiation, mate.
Alright, try example 7, please. Use the technique I've taught you.
Yeah.
Process is 1.
Wait. Yes, he's 1, yeah.
There's
Then you
no
get
other
that.
combination.
Wait, where did you get? Wait, how do you find separate?
Oh, well, you have the point 1, negative 1. Yeah. So you sub in 1 here and you equal it to negative 1. Because you have the point 1, negative 1 on the original graph. No. Because you got to first anti-differentiate this. You got to first anti-differentiate this. The f dash x. You got to anti-diff this to get fx. And e plus c there.
Yeah, but when you add differentiate this, you get this.
No, you don't. You get positive. Well, try. Okay, differentiate this for me, and if it's not that, then it's wrong.
Alright?
Differentiate this.
Now, example 7. Example 7 is actually pretty straightforward. If the scaling thing is, if you're not used to integrating string and e.
Yeah, negative half
Alright?
there, right?
So, I
Times
did
2
not bother even
should be negative 1.
animate
But
this.
here it's
So
positive.
what
I
I
think you got it
did
wrong.
was,
So you got
I
to
looked at this.
So,
I did a ddx or ddt
Sine pi
of
is
e to
equal
the
to
power of sine t. Alright? So that is equals to cos t e to the power of sine t.
So,
Correct?
So e to the sine pi is
0, right?
is 1.
So are you just down?
I reckon they go right to
E to the sine pi is on
0?
Yeah, but it's 0. But
0. So e to the 0 is 1.
E to the 0 is 1.
yeah, e to the 0 is 1.
Silly mistake.
It's too late when I was doing this. I think it was quite close to midnight last time.
Sir, you got to
Yes,
sleep.
fine.
How did you even do the first one?
Oh shit, I'm not the
So how do you
best.
integrate the first part?
Sorry? Okay, hang on. So, I concentrate the first part,
Oh, shit,
I concentrate
shit,
on
shit,
this.
shit, shit.
E to the power of sine t.
This one looks
Alright?
good.
Oh, that one's pretty
d dt e to the sine t is
good. Yeah.
cos t e to the power sine t.
Oh,
Because you're integrating that first. Cos t and then e to the power sine t is e to the power
I
sine
can't
t.
get it. I'll
So
go one
straight
more.
away you know that this is just that.
Let's do this.
See? You can bring a cos t up.
Put it in front.
That's it.
Oh, it's the same thing.
It's the same thing. The cos t could be in front, but it's just the way it is typed. It will be think about that.
Why do we focus on the e sine t? Is it because there's a power?
Yeah, it's a power. You always focus on the e to the power of sine
He
t.
didn't integrate that. He differentiated that.
No, he integrated.
Oh.
All right. So g pi is 1 minus e.
Well, when you differentiate sine t, you get cos t.
Oh.
So you're
All
going to
right.
bring it to the front.
Now,
Yeah.
there are quite a few questions for all of you to do on Google Classroom.
Sadler, sir?
Sadler as well as something else I can't remember.
Oh, you actually Sadler addict.
I'm a Sadler fan.
I haven't touched a single Sadler question this year.
I can't remember myself.
Don't.
Yeah, I've got optional
Well, I
worksheet
go,
as well.
I go to
Particular
Alphonse's
solution, optional
methods class,
worksheet.
so I do practice.
It's from Nelson.
So I do 2 hours.
All right, I'm going to stop here.
I don't do anything at home, basically, other than homework.